My name is Jim Pfister. I'm a contractor for SNIA, and you'll see me a little later today talking about a different program. I want to welcome you to the Persistent Memory Summit. I think this is going to be an awesome day. We've had a great organizing group led by Jenny Dietz, who's been working on this agenda for a good 3 or 4 months. We got some very exciting submissions, some good keynote speakers, or a great keynote speaker, some very good content through the day talking not only about the hardware around persistent memory, but the software environment for persistent memory and real life people doing development for persistent memory. So I think it's going to be a great and exciting day. Everybody pumped up? Yes. Come on, I know the coffee wasn't out there in the lobby, but get moving. So our first speaker is going to give us a good State of the Union. Everybody knows Jim Pappas. He's pretty easy to spot. He's pretty easy to hear. Jim is a SNIA board member. Jim is a longtime Intel employee who one of the smartest men at Intel once said, "Jim, you are the perfect guy for the perfect job for what you do," and I think we would all agree with that. I will also say Jim is very persuasive if he knows you like beer. Jim Pappas, come on up.
Today I'm going to talk about giving an overview of what's going on with persistent memory, where we've been, where we've gotten to, and you could guess from those of you who've seen me, I'll talk about this. I'll probably talk a lot about outer space, so because I just happen to like it, and I never talk directly about what we're talking about. I always talk in metaphors. It's just the way I talk. What can I say? So, a little bit about SNIA at first. This is, right now we have, this is pre-Persistent Memory Summit. We have people from the symposium in the room. I'm going to give an introduction on PM. Then we have our keynote speaker who'll be coming in, Andy Beckelsheim, this year. I think everybody knows Andy, and we're very, very pleased to have him here this year, although he hasn't shown up yet. So, any bets whether he shows up with his Birkenstocks and socks on? I mean, I think that's probably a given. I've never seen him anywhere, anything else. But about SNIA, we have about 185 companies involved. A couple of thousand people who are actively participate and volunteer their time. It's a volunteer organization. And we have a reach of about 50,000. So our mailing list and our people we influence is in that range. So it's a very, very substantial organization. So and I've had an absolute blast being on the board of SNIA since we brought in persistent memory into this in 2012, mid-2012, June 2012, in fact. I had the honor to present that to the SNIA board, and it was accepted. And I had also asked, that this is really important to my company. Can we come in and get a board seat again? And that was also granted. And it's been a very, very fun ride. Andy Rudolph's over here. I see him nodding. Andy is the chief architect, really, for persistent memory, and it's been a lot of fun. I will say, and I'll talk about this in a second, we really were not expecting persistent memory to take this long. It's hard. Projects are based on your previous experience. And so, for instance, my company, we built CPUs, and we there's a formula for how to do it. And things don't always work exactly the same each time, but you've done it before, so you know what kind of has to happen. When you're doing something new like persistent memory, it was very unknown from one step to the other, which is why I like to compare it to our space program. You'll see me doing this later. Because it was the same thing. It's never been done before, and when it hasn't been done before, you really don't know what to expect. So, back to SNIA. We've spent 20 plus years doing development standards, and Ken Gibson, I saw Ken walk in a while ago. There he is. Back when we were trying to decide, my company was working a lot on persistent memory, and I had the action item to figure out how do we standardize this. We were talking to many, many companies in the industry, and everyone says this is really cool stuff, but there needs to be an industry standard. And I think Ken and I made the presentation to our executives, and we recommended SNIA as the place to do it. It was approved, and that's kind of what started this whole thing off. So I'd like to acknowledge Ken's contribution to that. So so here's my portion of the talk. I'd first like to thank our sponsors. Without our sponsors, we could not do this event. And it's free. It's been free all the time, and it's not cheap to run. But it is. We feel strongly about this. It's important. So, and we could not do it without our sponsors. The SNIA Solid State Storage Initiative, soon to have a new name, by the way. Inside of SNIA, there's another new program called Computational Storage that's moving into the Solid State Storage Initiative, and there's a new name coming to be announced any day now. I think they decided the name yesterday, but I don't think it's quite public yet. I think it still needs to go to the board tomorrow. Those of you would have received a little card when you registered today. That gives, there's a new book on persistent memory that is just coming out. And he actually has a copy of it. And if you, with that QR code, you can get a free copy of the book. So if you did not get a card today, just stop by the registration desk and get one so that you can get the free book. That was, Intel had asked to distribute that at the conference. Instead of having a table, which was kind of came with the sponsorship, we decided we wanted to give out a booth instead. Come on in, Dave. And so MemVerge has got a table out here, Smart Modular and Smart IOPS. So thank you very much. So I'm going to go back and do a little bit of history here, and pick the last few years. And Doug Voigt made this slide several years ago, and it's a log slide. It shows where we have the media latency between various types of media, from memory or persistent memory, and then into various SSDs, and then finally hard drives. And it's on a log scale, so it doesn't really generate it. So if we were to unlog this, unlog scale it, and this is a smaller conference room than some, but if let's say that this was 18 inches on the screen, how high would the other things be if it wasn't a log scale? So SSDs, NVMe a little bit faster than SATA, but if you kind of average them, about the height of the Empire State Building. And then after, I'm not going to ask you to raise your hand if you still use a hard drive. I don't want to embarrass you. And this is done by the Solid State Storage Initiative, after all. Okay, I see that Tom Friend, who previously was working on hard drives, is giving me grimaces here, but it's back up. So the hard drive is, going to outer space here. About 2/3 of hard drives would be above the Karman Line, and Karman Line is 100 kilometers, and that's where NASA considers the end of our atmosphere and the beginning of outer space. So about 2/3 of it, so we're up in spacecraft territory up there. So we kind of did this to poke fun a little bit at what these latencies really are and what 6 orders of magnitude feels like, and looking at at the time most people were still using hard drives, and we were talking about 6 orders of magnitude of latency removal, and architecture is probably going to change significantly. Then the next year I did something totally off the scale, and I wasn't really sure. I wanted to use a space theme, and I just woke up one morning thinking about You remember hydrazine and nitrogen tetroxide? I mean, who's going to forget when we talked about that? I'm looking at Nathan. Nathan, I'm sure, remembers that one. And it was used as a metaphor. I told you I always talk in metaphors. But, you know, these two components, when you touch them together, only one possible thing can happen. They're hypergolic. They start burning. You don't have to give a spark. You don't have to do anything. If you just open two valves, and that's what goes on in like the command and service module and the LEM that lands. They use nitrogen. They use hydrazine and nitrogen tetroxide, and they don't have to do anything. We've always gotten the astronauts back because you open two valves, the stuff mixes together, and there's only one thing that could possibly happen. It just burns like hell.
And they say rocket scientists are really the smartest.
There you go, right. So, and of course that was a metaphor for if storage and memory come together. If you know, realize at the time we have not done any of these new technologies, you know, to be able to scale them and put them into manufacturing. But if in fact they come together, something will happen, and that is there'll be an architecture disruption. It's got to happen. The benefits are so outrageously changing. You know, 6 orders of magnitude. No other possible thing could happen. And then after the next year, I didn't do too much about space then, but when Stephen Bates, and unfortunately Stephen's not going to be here today. Stephen's family is sick, and so he's up in Canada nursing his sick wife and kids. I think he just recently recovered himself. So he won't be coming, but in the middle of his talk, and I don't think oops. Oh, there we go. In the middle of his talk, he was talking, I don't remember the exact sequence, it was probably something like, you know, how you do this stuff, and you do an S-fence operation, then you try SCE to ox, and then you do a PM flush. And he said it, and kind of nobody kind of caught on, but he looked at me when he said it. And I'm not going to go through the story on trying SCE to ox, but those of you who don't know what I'm talking about, Google it sometime. It's just a great, great story about this very young engineer, straight out of college, 22 years old. He's sitting there in mission control at the thing, and it was a couple years later when this was Apollo 12 actually, when he saved the lives of the crew more than likely, and certainly saved the NASA program. It's just a methodically great engineer, the engineer of engineers. The steely-eyed missile man became his thing. And I won't say more about this, but you know, it's when we're off debugging something and we can't figure out what it is, you know, I oftentimes say, well, just try SCE to ox. And it's up to you. If you don't like to Google, and just catch me in a catch me in a break, and I'll tell you the story. So, buy me beer. So here we are, 2020, and what am I going to do? Of course, I'm going to talk about space. It's not really a question mark. So, thinking over the last few days, where are we in this program? And as I said, we started this in June of 2012. That's 7.5 years ago. So 7.5 years after we started this thing, Apollo 7. That was the first manned Apollo mission, was Apollo 7. It was supposed to be Apollo 1. It was supposed to be the first, but we lost that crew on the ground in the fire. And things changed, and there was a delay. I told you, persistent memory is taking longer than we thought it would take because everything is new. Well, the same thing happened. So they were behind schedule, but that was 7.5 years. And if you go from June of 2012, we're 7.5 years into it. So we are there. So, and there's this one event that really, pretty much everything has to be done before you could go on, and that is clearing the tower. When you, and that's where I think we are with persistent memory right now. You know, if you, clearing the tower, this is probably the most dangerous phase of the flight. Spacecraft is sitting there right up against the tower. Any of dozens of system failures, a bad burn, guidance software being off by minuscule amounts, anything. You have, the astronauts are sitting on 450 tons of liquid rocket fuel with enough energy in it. I don't know, it's relative to atomic bomb, I think it's like half of atomic bomb or something like that of energy. I don't know the exact numbers. But, you know, everything could go wrong, and clearing the tower is a critical step. One more thing too, when the commander, you know, says we have cleared the tower, you know, he says, you know, the clock is running, and then the second thing he says is we've cleared the tower. That's when the Kennedy Space Center says, Houston, they've cleared the tower, it's over to you. And from that point on, Houston runs it. And the thing I liked about this, and I hope I don't upset anybody because I got this wrong, but the first system shipping with persistent memory was, in my recollection, was an HPE system with NVDIMMs. I can't remember which vendor, but it was the first OEM, and of course they're a Houston company. So I just want to do a shout out to our friends at HPE. I think they were actually HP at the time, but you know, it took a lot of firsts to make to get us here. So we cleared the tower. And so I have some proof points of why do I think that we're at this point. And you know, going back to NASA, going back to Apollo, and never having done it, they had, you know, 7 things that they needed to get done. And it was things like, you know, we need to build the machine to get us there. We need to build a suit that will protect people in space and on the moon. And we need to be able to do an EVA. We need to leave the spacecraft, do a spacewalk in space, and get back in. Can we do that? Can we get out? Can we get back in? Will it all work? You know, we need to do long duration flight. We need to do rendezvous. We need to take 2 spacecraft. We need to rendezvous. We need to find each other, get there, get in the right configuration, then we have to dock. These were all, there were 7 different steps that they needed to do. Long duration space flight was another. Can you actually go up there and spend a few weeks? That's what it'll take to go and come back. Can you actually do that? Will the human body live through that? So they had to prove all of these things one after another. And I arbitrarily picked 7 big things that we needed to do in order to make persistent memory happen. So we needed the standards. And as I said, we did this in SNIA. And very, very appreciative to SNIA on this. We have to get media. We have multiple medias right now, and several more arriving. Dave Eckelstein will be talking about this later in his talk. At this point, most or all OEMs and ODMs are now shipping, having some SKUs with persistent memory in them. Major, major accomplishment, both with NVDIMMs and other native persistent memory technologies. Probably one of the things that we did, and because of, and I'm looking to Andy over here, because of the programming model that we delivered, both Windows and Linux have almost exactly the same APIs. And the chances of this doing without having that programming model and that level of clarity was about 0. And big, big step. And we have, in fact, the OS companies outperformed the hardware companies delivering the products behind that. We had OS support before we had really stable, available hardware. A remarkable, remarkable achievement. We now have hypervisors. We have actually 2 VMware is giving 2 talks today. And if those of you remember when we had Scotty Miller from DreamWorks on stage a couple years ago, and people asked him, you know, how can we deliver this to you? He said, through the cloud. And he said, you know, that's how I need it. And we have 2 cloud vendors at least now. I know that both Google Cloud Services and Azure have both publicly announced availability of persistent memory instances. Sometimes they're specialized, like for instance, like to make SAP HANA as an example initially, but that's how these things start. And it's out there. The technology is starting to have things. And then finally, applications. And we have several, not enough. And I think the biggest reason is because we have, oh, I have to hurry. Because we, in order to get the entire industry doing it, fear drives it. And you know, when you see applications coming out and you see the benefit, and we know that the inherent benefit is there with the orders of magnitude of improvement that persistent memory brings, companies will start fearing that, oh my God, this is really happening. Where's my program? How do I get involved and stuff? And we'll see an acceleration. Under development, working on more applications. We have, SNIA has taken the ball and we've been driving it from the base up. We running hackathons. Jim Pfister, who is the new Jenny Dietz for today, he is running that, and we're taking responsibility to kind of create. Our goal is to create this ecosystem. And then new hardware interfaces. Stephen Bates' talk is not going to be given by Stephen, but we'll have Milind Mittal coming in here later on. He's Mr. C6. He was the key architect for C6. He'll be talking about CXL today. And new media, also Dave. So these are all things that we still have ahead of us, but we are very, very far along at this point. Yeah, it's really real. This is on Jim's hackathon program. Amazing. We hired Jim to do this thing in December of last year, late December, like December 28th or something like that. I think I gave him the call. And he actually had the first hackathon a year ago, you know, essentially today, at the day of this event. And he's since trained, it's over 325 or there people have come through the hackathon training. He's got an award program, a competition going on for, this is running on NVDIMS. And I don't know, you're gonna have a couple of surprises today? One demo out there. One demo out there, so. Yep, I know. Okay. And then, as I said, CXL is coming. CXL will be a new attach point for persistent memory. And it's because we really, you know, right now, persistent memory sits on the same bus as DDR. And it's really a lousy place to do it, to be honest. For one reason, you know, it's intuitive that the more persistent memory you have in, the more DRAM you also need. And of course, but we're trading them off. You don't really want to have to trade them off. As one grows, you want the other to grow as well. So the persistent memory will be moved off of that bus. It'll be moved onto its own dedicated interface, one that's better. And you have a talk on this later on that Milind will be giving. And there's our agenda for the morning and afternoon. And with that, that's the end of my talk. And, oh, one more slide. Did you throw one in there for me? Oh, okay, yes. So enjoy the summit.